All right, so in the last video, I quickly kind of glossed over the um, classifying of numbers. And this is where we're actually going to use those classifications. Because it's great to have their definitions, which was like 3 slides back. But it's easier to see them visually. So what I have here is, and what you have on your slides, is that they're Venn diagrams. So just if you remember how a Venn diagram works, what overlaps is the same. So in this case where we have, I've got rectangles within rectangles, right? Those rectangles, everything within the smaller rectangle is part of each of the bigger rectangles. So we're going to start with our natural numbers. Maybe if it'll write. Natural numbers. So these are the numbers that we just naturally count with. We call them natural because these are the numbers that probably started the world, right? Or within the world. And so those would be our 1, 2, 3, etc. All right, from natural numbers, then comes our whole numbers. And so that's our natural numbers with the number 0. That's the only thing that gets added when we start talking about whole numbers, is that number 0. From there, then we start talking about integers. And integers are when we start adding in the negative whole numbers. So the opposite whole numbers and their opposites. So that would be like -3, -2005, -27, right? Negative whole numbers are considered integers, or whole numbers and their opposites are integers. And then we go to rational. Yeah, rational numbers. And that's when we can start writing these as fractions. So like 2/3 and -7/8. Terminating decimals, so 0.25, or repeating decimals, 0.12 repeating. Our improper fractions, so 7/3, or 2 1/8, right? These are all rational numbers, along with integers, whole numbers, and natural numbers, because those are all terminating decimals, or we can write them as fractions, like -3/1. Bada bing, that's a fraction. And then the opposite of rational would be irrational, because ir means not. So like if you're irregular, you're not regular. So irrational. And so those would be things like our non-perfect square roots. I guess I should have put square roots in some of these. But our non-perfect square roots, like square root of 28. Whereas square root of 25 would be a natural number because its answer is 5. And then it goes into these others. Integer-wise, I could do a negative square root of 16. Because square root of 16 is 4, so that makes that -4. Our square root fractions could go in the rationals, but irrational would be a non-perfect square root. Also, numbers like pi, because it never ends. That decimal goes on forever and never repeats, right? So those would be different ones that fit. So like 101. Okay, so those are irrational. And the thing is that all of these numbers are real numbers. And you may say, why do we have to call them real? Because when you get to algebra 2, then we start talking about imaginary numbers, because mathematicians said, well, if I could solve this problem, what would my answer be? Because they just want to know answers. But the numbers we work with on an everyday basis, they are real numbers, and then we classify them in this way. So until next time.